Welcome back to Advent of Code 2023, day 12. I like how this diagram here is a pretty accurate map of where we've been. So we started off at what? Snow Island with no snow. Then we went to the island because it has islands. Oh, there, look, there's the islands. And then we went to Desert Island, and then now we're on Metal Island. Okay. All right, day 12. Hot Springs. Sounds familiar. Thought we already were at Hot Springs. You finally reached the Hot Springs. You could see steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. They're hot springs, though, technically. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helixes towering overhead. This way. It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. Oh my god, there's a shortage of everything. So... Snow Island had a snow shortage. Island had a... What, a water shortage? Desert Island had a sand shortage. Metal Island has a lava shortage. You ask about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment, not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Okay. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. This is really sounding like Mario RPG now. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged are also damaged. You'll need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. Each row, the condition records show every spring and whether it is operational, dot, or damaged, hash. This is the part of the condition records that it is itself damaged. For some springs, it is simply unknown. Okay. However, the engineer that produced the condition records also duplicated some of this information into a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. Okay. This list always accounts for every damaged spring. And each number is the entire size of its contiguous group. That is, groups are always separated by at least one operational spring. So this would look like 113. This, well, we've got the 3, we've got the 1, so we know the remaining must be 1. So it's kind of like solving something. We're solving something. However, the condition records are partially damaged. Some of the spring's conditions are actually unknown. Okay. Equipped with this information, it is your job to figure out how many different arrangements of operational broken springs fit the given criteria in each row. How many different arrangements? Really? Because it could be loads. Well, I mean, in the most, there's 2 to the power of the number of question marks, I suppose. So what are we looking at? And that's not much. So we can actually just brute force try all combinations. It would be 2 to the 10 at most. It looks like, which is 1024. And even a bit more wouldn't be too bad. Okay. There's exactly, well, and then for each one we try and see if it fits the contiguous pattern. There's exactly one way can appear. Alright, so for each row, count how many arrangements and get their sum. Okay, easy enough. If we, well, not that easy. Oh wow, there's a lot. So there's 1000. Okay. Alright. Oh, sorry, I left it on that screen. Horrible white. Blinding white. Alright, so we want... okay, just get something like this. Okay, so we want to parsing. We want to split by space to get the 2 groups. Okay. So we should just say... Alright, first just extract the information. Don't try to do anything clever here. So, we don't need to. Well, okay, so we could... Alright, just the first one, just make it a list. Just say L equals list. Alright, just turn it into a list, so it'll be list with these things in. And the right, it could be integer list. So right equals int x for x in r dot split on the comma. Okay, in that case, let's make a method here. Define num arrangements. So given a pattern and a... No. Pattern is the... What did they use? What is the term they used for the right hand one? The records, condition records. Yeah. No. Okay, the right hand side thing is the pattern, I would say. I would call that a pattern. The left hand thing is a record, I guess. I don't know. Let's just return 0 for now, okay. So ultimately we just want like that. Okay, right, so I mean, the tricky bit, of course, is working out the number of arrangements. Alright, let's make sure it compiles everything. Okay. Alright, so I would say first we want to find out how many question marks there are. So wild cards, let's call them wild cards. Wilds equals record.count question mark. Alright, now we probably want to use iter tools, good old iter tools. This is one of the great things about Python, iter tools. And we want to use, what do we want? We want, no, not permutations, we want, I always forget which what methods are in this library. Python iter tools. So we've got accumulate, batch, chain, blah, 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 blah. Is it permutations? No. Permutations doesn't allow repetition. Combinations with replacement? Yes, combinations with replacement. What a mouthful. That's what we want. So for combinations with replacement, so we want so it's going to be dot and hash is the things we're allowed to pick, and the number we're allowed to pick is wilds. So ARR will give us a, should we just try printing ARR? Let's have a look at what it looks like. It's beautiful. So it gives us every... No. This isn't right. It's not giving us every... Combinations with replacements. This is not every permutation, though. Is this not doing what I thought it would do? Combinations return R-length subsequences of elements from iterable, allowing individual elements to be repeated more than once. Oh. Oh, I see. They're allowed to be repeated contiguously. Okay, that's not what I want then. What do I want? Product? Maybe it's product. Yeah, product. Cartesian product. That's 2 to the power. That's everything. Cartesian product. Sorry, not Cartesian product. Power set, right? Alright, product. You give a bunch of things. Okay. What we want is product. Repeat equals wilds. Alright, try this. That's going to go on for a while, but what it should do is print every possible... There we go. Every possible permutation. Alright, got it. Alright. Product. Combinations with replacement. So that... Oh, I get it now, what the combinations with replacement. It's like... You are allowed to replace the thing you just... Oh no. I don't fully understand that one. I'll have to read about it. Alright, so anyway. We have an array. Okay. So, we want a new... we want to create a new sequence which matches the pattern that we've just created. All right, let's just build this. So sequence is that for car in record. If car in dot hash sequence dot append Else, if it's a question mark, we want to just put what the product has given us, so just pop from the array. It doesn't matter if we've taken the end, because we're trying every permutation. Alright. So now we end up with a sequence where we have plugged in some values. And now we want to see if this matches the pattern. And if it does, then we add 1. So what do we do now? We want to just there's got to be a nice easy way of seeing whether breaking this up into Alright, well what we could do is just check from the oh, I'm overthinking this. Maybe if I just do one massive for loop. Alright, fine. So just well, just look from this. I don't want to do too much work here, so I don't want to be cutting and slicing this list up too much. This should just be a linear time scan. So let's just say if right. Step I equals 0. Pattern iter equals 0. Right, so we're checking the beginning section of this against the first element of pattern iter, which is going to be a number. So we want to see that the first, if it's 3, if pattern iter is looking at 3, then we want to see that the first 3 things are contiguous, right? So while while I is less than length of sequence, and I guess this is what you have to do. Alright, so we check so while we want to include that. Then we increase j until we no longer have a contiguous block. Right, so I to j is contiguous. All right. So far it matches, and as soon as that goes false, then all right. So then we move on to the next pattern. All right. So once we're here, we have I up to j is one contiguous block. So if j minus I, that's the j minus I, that's the number of things here. Is not equal to pattern then match, then we've failed to match, break out of this while loop. All right. So otherwise, just move on to the next. There's got to be a better way of doing this. I'll think about this next time. Because this comes up in lots of problems and I keep writing hacky solutions to it. Alright, so pattern item move. I becomes j, pattern item moves. Alright, so that goes on until we've hit the ends. So if match and, because we have to make sure that I has actually reached the end, because we've got to match perfectly. So see, a better way would be just to extract all the numbers and then check that whole tuple against pattern iter, but I'm trying to short circuit here, so it's dangerous. Okay, if so I should now equal the length of sequence, and pattern iter should now be at the end of the pattern. Everything should have lined up perfectly. Then result that's equal 1. Right, if I just run this now, we have to make a list that we can actually pop. Right. Oh, it's going to take a while though, but I don't know how long it's going to take. We need it in 0. Nice, because what? If match and I Alright, we're gonna have to have a look at what the heck is going on then. Let's make sure first that we've got we're passing the right things here. So we've got print sequence. Alright, I'm gonna have to take a quick break. I'll have a think about what I might have done wrong here. So yeah, that looks like a sequence, or the correct sequence, and we're trying to check if that sequence matches the pattern, right? So we're trying to check that this matches that. We're trying to check that this matches 7, 7. I'll be right back. Okay, so what's going on with this? So there's got to be a better way of doing this. So what? Okay, let's just try and make this work, because I'm expecting this to work. So pattern iter, okay. J is the next one. So then I is replaced by J, pattern iter plus equal 1. So we should have Should we just start with an easy example where we know we should find matches then? So use the example from here. Alright, we'll just take this one here. It's just this one line. Okay. 0. Okay, so it's 1. Oh, hang on. I've misunderstood. What the record pattern is actually saying. It's not, of course it's not describing the, okay, it's describing the contiguous group of damaged springs, i.e. hashes, only, not contiguous groups altogether. That wouldn't even make sense. Whoops. Okay, so it's only describing the hashes. This makes it actually easier, so we don't need to do all this. We can just say we can just do there's a way easier way. We could just use Python's split method, couldn't we? So we could just say, so we could so we do join up the sequence now. Right. And now split on dot. And then piggyback off the split logic. The split logic will kind of split it into hashes, splitting on the dots, right? And then we'll have a bunch of elements. So it'll be length x or x in that. So that will basically be a tuple describing the lengths of contiguous. So that should match the pattern. Pattern must be a tuple for this to work. Okay. So we just want. So all of this is unnecessary. Take this out. Result plus equal. That is the same as pattern. So we want to see if this matches the pattern. Bool object is not. Oops. There we go. Just put the bracket in the wrong place. 1. Perfect. All right. So let's just try the input fully. the example input. Only one? Damn it, that can't be right. So for the first line there's 1. For the second line... it's 4, then 10. Oh, come on, what? How have I only found 1? I'm checking... Alright, we have to do some investigation here. So we got to look at what this looks like. Let's say... make sure these patterns are correct. Alright, so we've got, for example, here we're saying this is 5. Oh, it puts gaps here, but that's... I thought... Oh, because split... Oh no... Because it's different if you do... So I'm used to the way that it handles white space. It removes all blocks. Okay, fine. Let's just put if x is not an empty string. All right, just filter out the zeros then. All right, looks like we're getting somewhere now. 21. Is that right? 1411421. Yes, that's correct. Okay. Okay, this might take a while, but I mean, shouldn't take too long. Well, it's at most 1,000. It's at most 1,000,000 arrays to deal with. Okay, 7,025. Correct. As you look out at the field of springs, you feel like there are way more springs than the condition records list. When you examine the records, you discover that they're actually folded up this whole time. To unfold the records on each row, replace the list of spring conditions with 5 copies of itself. Oh, fuck. Separated by... And replace the list of contiguous groups of damaged springs with 5 copies of itself. So this row would become Oh my god. So oh no. Alright, let's make sure we just get the... Okay, so part 1, we can do that, but we can't do that anymore. Brute forced. The number of permutations is too many. Because it's 5 times, so 2 to the power of 50 is way too much. Fine. So let's just make sure we are getting the input correctly. So we're gonna have to do alright, so when we get this, so L equals line.strip.split. Alright, so L equals, so it's gonna have to, before we do, okay, so L1 and R1 is that. Alright, that's part 1. Alright, L2 equals list of wait, so it said 5 times separated by question marks. Okay. So we can do question mark dot join. So it's going to be L times 5. So that creates 5 strings of L in a list and then ties them up with question marks. And then R2 equals... and then just turn that whole thing into a list. Do we really want a list here? Why we don't want to we want it to be immutable actually. So actually we probably don't want a list to work with lists here. R2 is gonna be, so they said comma Ah, okay, so R2 is just, R1 times 5, right? Just make sure this is coming out correctly. Let's go with the basic input as well. Oops. So that looks like that now. And this 113, 113, 113, 113, 113, okay. Oh, bloody hell. Okay, alright, so we've got the... We've got all the information we need. Now what? We're trying to find out how many ways a pattern like that could match that. Alright, what can we do? Maybe it's some sort of dynamic programming? Because, I mean, look, if you see this at the end, that's useful, right? You know that the 3 must match the 3 at the end. If you see this at the start... Yeah, this is dynamic programming, isn't it? How do we make this rigorous? It's about so okay, we don't really want to do all this. Let's start a new arrangements method, right? Define num arrangements 2. Alright, so we've got a record and a pattern. So I think we basically want to create a subroutine which does the same, which tries to find the number of arrangements from just the first I characters of record. Wait, no. What am I trying to do? Alright, so to find a subroutine, let's say, just, I don't know, num arrange. And this, we use a value I and j, okay? So this is saying, I want to match the first I characters with the first j numbers in pattern. So the upper level method is just I and j are equal to the total, right? But here, we can memorize all the possible values of I and j. So So for example, have I reasoned that out correctly? I'm trying to just take the first I characters and the first J numbers of this. Alright. Just create a table here where we're going to store some stuff. If ij in table, return table ij. So ultimately, we want to return num array with I equals, so it's going to be length of record, length of pattern. So it's all up to this recursive method, the dynamic programming approach, to work out the intermediate ij values. Okay. So if we already know ij, we return table ij. Okay. If I and j equals 0, then return 1, I suppose. There's only one way that can be satisfied. Okay. If I is 0 and j is not 0, then it's impossible to turn 0 because we've got a pattern of, we've got basically an empty string, and it can't match any pattern because there's no springs whatsoever. Okay. If j is 0, what then? We want no springs. So basically, return so we want it all to be dots and question marks, so we won't return true if there are no hashes in those first I characters, right? Return all is not equal to hash or in or just say record k is not equal to hash for k in range I. Okay, so those are all the base cases I can think of. Otherwise, we now have to do the smart bit, work out how to reduce. So we've got I is not 0 and j is not 0, so we're working with at least one number here and at least one character here. Okay, what do we do? Well, if so we're trying to check the first I characters against the first j numbers, right? If the last of these characters is a dot, we can actually just kind of reduce and move on to the next one, can't we? Because we know a dot is worth nothing. It doesn't contribute anything or cause any permutations or anything. We can just put... So if our last character is a dot, just reduce I by 1 and then recurse, I suppose. Alright, so if record the ith character oh, hang on. Yeah, if record I minus 1 is a dot, actually we probably shouldn't do this because that's like linear time. Let's try and stick to constant time. Operations. I'll think about that. Alright, so if it's dot, then we return num array I minus 1 j. Alright. A dot is... we can just filter that out and nothing will change. Okay. If it's a hash, see, if it's a hash, then we actually need to change the pattern. Damn it. Can I actually do that? No, I can't modify the pattern, but I can introduce a delta, like an additional parameter here, but that's... What am I trying to do here? I don't think we can just look at the last character, can we? So if I is like these characters, alright, so if I was this question mark, what would we do? We would try dot and hash. Alright, if it was hash. Then think we do need to introduce a delta here. A third parameter. Then we recurse, but we subtract 1 from the final, from the element of the pattern. So if it was 3, and we see a hash, we kind of reduce I by 1. But we also reduce the size of the last pattern, so... Oh man, is this really what I should be doing? And anyway, that should be an int. There's probably a different approach, but similar to this that I should be using. Let's think. I think that's what I need to do. I think I need to introduce a delta. Okay, fine. So we've got this thing called delta now. And delta means whatever the last element of the pattern is, whatever the jth element of the pattern is, we subtract delta, okay? So it's going to be ij delta in the table now. So we increase the factor now. So if I is 0 and j is 0, wait, also, we need to make sure this delta is valid. So if j is 0 and delta is greater than 0, I think that's an error. I don't know why that could happen, but I don't know. Return 0, because there's no possible arrangement that could satisfy that. Delta shouldn't apply there. Alright. If j is greater than 0 and delta is strictly greater than pattern, the jth item, return 0 because the delta is bigger than the pattern element. That's also an impossibility, so that should not have there's no possible arrangement which would satisfy that. So otherwise, I know this is so many edge cases, so otherwise we know that delta is a valid number that can be applied to j, alright? We've checked the two possibilities where delta doesn't make sense. Okay, Wait, what if delta is equal to... Oh, for goodness sake, this messes things up. If delta equals the final pattern element, then that makes it a 0. So we should probably now just move to the reduce j by 1. Oh my god, this is so many different weird cases. I don't know if this is gonna work. Alright. So I think I've handled every weird value of delta. So the only other values it could be are just a portion of the j pattern element. So it's cutting off a bit of it. Alright, so now we can incorporate this delta. So we do... if delta is pattern j minus 1, then return num away. Yeah, that's correct. We'll make it mandatory. So here it's going to be 0. Alright, so if it's a dot, then yeah, we go to the next one. That's fine. If it's a hash, then we want to go to the next one. With an increased delta. Right, that's the key here. Because, and if delta meets the pattern, then we move. Okay, so this is all kind of resolving. I'm sure there's a better way I could have written all this, but I'm trying to cover all cases here. So, all right. And then the last case, this is the big one. If it's a question mark. I suppose we just want to return literally both of these, right? Sorry. Yeah, we want to try both dot and hash. Add the two together. So it's going to be... So we'll take that plus that. Oh god, does that all... Okay, was this going to do something? If I don't know if it will even give the right answer, but it will hopefully do something. So let's try num arrangements 2. If we're lucky, we'll get 21 again. Alright, we'll hide this. 172. Okay, we're way over now. Oh, because I forgot to put things in the table. Well, no, that shouldn't matter. Okay, put... Oh, because I'm doing all of these if cases. I'm not using the table. So that's return 0, return 0. Probably don't want this one. No, that's fine. That one's fine. If delta is that, yeah, okay. Alright, all the ones where I'm recursing. Right, let's move these. Okay, move that down. Alright, so now these are the ones where I'm recursing, so I want to say result equals on my way. Alright, I don't know if I even want that one. J equals 0. We'll leave that in for now, but we might want to take that one out. So the only time we move to j minus 1 is here. That's where the delta comes in. So finally we say table of ij delta equals result. This allows us to recurse. Return result. Now we get 0. Well, I didn't even change anything. Oh, because these need to be elifs. $105. Better. This is very unreadable. I don't think anyone watching will actually understand this now because I've got something weird in my head. If it all goes to hell, I might start fresh and try and draw a proper diagram of what's going on. So if delta is... So delta is just a number which increases and tries to match the last element of the pattern. And when it matches, then we move on to the next J. We discard the last element of the pattern and move to the first few. So move on to the next element of the pattern. So we're trying to match these pattern numbers against the number of hashes. As soon as we've seen a hash, we increase the delta. And then when it reaches this pattern amount, we kind of move to the next J. Okay. If J is 0, I don't think we need to do this. Right, because if J is 0 and delta is greater than 0, then we'll handle that case anyway. So that's already handled. Get rid of it. 105 still. Okay, fine. So we've got a number out of this. Now I just need to figure out why it's wrong. Let's go with the most basic example then. This, we want to get 1 out of this. One. Okay, it works. It works for that basic case. All right. Okay, so the next case we want is this. This should yield 4. Okay, let's try and figure out where this has gone wrong. So we start with I equals length record. Yeah, that's right. So these are basically the pointers of the end of the length pattern, and delta equals 0. Yeah. Okay. Does this cover all cases? Should we just look at what the table is then? Alright, so do these numbers make sense? So let's have a look. 1, 3, 2, 0. So it's saying we're trying to match the first character against the first 3 numbers. I mean, if I is less than j, it's not even possible, is it? We can make this stronger if so. If I in fact, if I is less than or equal to j, it's impossible. If there's 3 numbers in j, then there has to be at least 1, 2, 3, and then 2 gaps. So you would need at least j plus, so basically 2j minus 1. So if I is less than 2 times j minus 1, return 0. Does that make sense? Alright, better. Alright, what else? 5, 3, 2. So we're trying to match the first 5, 1, 2, 3, 4, 5 characters against the first 2 numbers. 1, 1. Well, that can't be done, can it? Oh, I've made a mistake here, haven't I? Oh, I'm trying to... okay, I'm close. But I'm not even accounting for the gaps. Oh, wait. Oh, man. So I'm allowing 1 and 1 to be next to each other. Wait, how do I account for that? Fuck. Is there an easy way to fix that? So I'm sort of correct, except I'm not allowing for gaps. So it's counting... Oh no, but that's correct. It's 0. There shouldn't be any possibilities. 1, 2, 3, 4, 5, 1, 1. No possibilities. Okay, that's correct. But still, I'm not handling the gaps correctly. Let me think. Alright, so if... This is the key step. When delta matches pattern J-1, we need the last ith character to now be a dot to signify a gap. Or a question mark. Either way, so if record I-1 is a hash, then we have a problem, right? Because we're saying we've matched our delta. Let's say delta was 3, and the pattern item was 3. That means we've found 3 contiguous hashes, okay. But now there's a hash, there's still a hash, just to the left. So in that case, we want to say this is not possible, because that means there's a contiguous element of 4, but our pattern was looking for 3, and there's no gap. Okay, return 0. So in the other cases, if it's a question mark or a dot, then we want to ignore the final character there, because we don't need that character now. That character serves as the gap. It needs to be used as a gap. All right, let's see if that improves it. 4. That's correct. 4 arrangements. So I wasn't accounting for the gaps correctly. Oh my god. Still not confident. All right, let's check this one. One, correct. Should we just try the whole lot? If we get 21, I'm happy. Three? But I got... What? We should be getting... We should be summing... Hang on. I'll hide that. How can it be 3? Are we getting negative numbers? What? Zero one one zero zero one three. Well, but I but I was getting the right numbers earlier. Hang on. So what's going wrong here? There's number array, length record, length pattern. I don't understand. So for this one here, I was getting 4, right? One. What's good? What? Print 1. Well, what am I printing here? Okay, ignore the total for now. 1. How did I get 4 earlier? And then if I print the table. What did I change something? Alright, what did I just change? It was working just a second ago. Okay, so that should be 113. Should be 4. It should be 4. I had 4 earlier. What happened? Why is it only ever 1 and 0s now? Result equals... Also, why am I putting 0 here? I think... Oh no, that's fine, yeah. That's when we move on to the next one. Is this here, is this too harsh? Hang on, if I take that out again. No, it's not because of that. What did I change? Alright, we're gonna have to debug this now. 1, 1, 1, 1. Everything is 1 or 0. Everything's... There's no zeros. Well, zeros don't normally get put into the table. Alright, let's see. 1, 1, 1. So we're saying first character matching the first pattern. That should be an impossibility. With the delta of 1. First character matching the first contiguous thing. That can't happen. So why is that giving us 1? So let's go through the steps. If it's in table, okay. If J is 0, no. Alright, if J is greater than 0, okay, no, it's not that. Alright, if I is 0, nope. If I is smaller than, nope. Alright, so it's here. Delta is equal to... Hello, Amaro. Alright, so it's this hard one today? Yeah. Yeah, it's pretty hard. I think it's a dynamic programming problem. I've made a really messy dynamic programming method. I could start again from scratch and make it cleaner, but I think I'm on the verge of getting it correct. Alright, so if delta is 1 equals... Okay, so we're into this case. So if record is a hash, return 0. That's not the case, okay. Otherwise, return... We reduce I to 0. J to 0. And delta to 0. So we should go to the 0, 0, 0 case. And that should return... That's correct. That there is correct, because we've got the deltas. That should cancel out. Okay. Let's look at the cases without the deltas. Here, 2, 1, 0. So we're saying the first two characters we want to match against the first J without any delta. That says 1. Okay, that's correct. Oh, I'm copying the wrong thing. Where's the question marks? I missed out the question marks. Oh my god. So this is correct, but it's fixed. Alright, I need the one with the wildcards. So it might have been that I was just correct all along, I just had the wrong input. 28, I'm slightly over. Damn it. Alright, so 0, 4, 1, 0, 3. The first case is wrong now. Okay, so what's wrong with this one? 5, 3, 2. So 5 against the first three numbers. That's definitely impossible. And we correctly say it's impossible. Okay. Oh no. Yeah, it is impossible. Okay. 6, 3, 1. 1, 2, 3, 4, 5, 6 against all three numbers. That's impossible because we don't have... Okay. 7, 3, 0. So all the characters against all of these. It says 0, but that's wrong, isn't it? But we're not... Why aren't we... Why aren't we correctly going to the subcases, recursing? 730, it's immediately saying 0, so one of these things is applying, which shouldn't be. So let's see. 730. Delta is 0. I is... Alright, so it's not here, it's not here, it's not here. It's not here. So what about this? So... No, it's not that. It's not that. Alright, so we're going into these cases. If the last character is hash, we fall into this case here. So we go to six, 3, 1. So that's why we recurse on this one. 6, 3, 1. Oh! I think this one's wrong then. 1, 2, 3, 4, 5, 6. Six, 3, 1 is 0. It shouldn't be 0. It should be 1. So what happened here? So in this case, we again look at the next hash, right? And we go to 5, 3, 2. Okay. Okay, 5, 3, 2. So then 1, 2, 3, 4, 5. And we've got a delta of 2. Now what happens? Um, 5, 3, 2. So we're saying we want to see how many ways 1, 2, 3, 4, 5 matches 1, 1, 1. Not 1, 1, 3, 1, 1, 1, because the delta is 2. So the answer should be 1. Why are we immediately saying 0? Which case is saying 0? Delta equals, so it's not this case. 2 times j, 6 minus 1, 5. No, it's not this case. It's not any of these cases. It's one of these cases. Okay, so hash. It's a hash. So we go result equals, so we should be going to 4 3 3 4 3 3 4 this shouldn't really be applying until we've resolved the delta. This is a weird order. Got this one here. Because if the delta matches, it's kind of like the J is invalid. It needs to be reduced by 1. Okay, let's try that. That didn't fix it. All right, anyway. So 5 3 2 4. So we went to 4 3 3. Didn't we? Five, 3, 2. Goes to 4 3 3. What happens with 4 3 3? 4 3 3 matches this one. So we go to 3 2 0. All right, good. 4 3 3 goes to 3 2 0. 3 2 0. So we're going 3 2. So that we're expecting to get 1. Instead we get 0. So what's happened now? 3 2 0. So that, I believe, three. So we should fall into this method here because it's a question mark. So we work out 2 2 0 and 2 2 0 and 2 2 1. 2 2 0 and 2 2 1. So 2 2 0 is impossible. Okay, so that should return 0, that's fine. So 2 2 1 is the one that should return something. 2 2 1. So it's going to be 2 2 with the delta of 1. Delta matches here, so we should then fall into here and go to 1 1 0. Okay, we've fallen all the way, we've recursed all the way to the correct final thing. Now, why is this one returning 0? If we can fix that, we might fix everything. So it's 1 1. It's literally matching that character. Next, this is so messy. Yep, welcome to the world of dynamic programming. 1 1. Not a good boy today. I mean, is yours cleaner? This is what dynamic programming looks like. This is that's actually not that bad, to be honest. I've seen much worse. In fact, I don't even think that's messy. That is genuinely the subcases you need to deal with. So I've handled each case one by one. I don't think, unless you take a different approach, I don't think It would be messy if I didn't separate out all these cases and tried to jumble them up into one. So I think that's actually as clean as I can make it right now. Alright, so 1, 1, 0. 1. One, 1, 0. So it all comes down to 1, 1, 0. Why is it saying 1, 1, 0 is 0? So it all comes down to this bit here. Result equals, so it's going to be 0, 1, 0, and 0, 1, 1. Ah, so I think this thing really needs to come at the start, because this trumps all. Well, except these two need to come first because these are checking for impossible situations. So we need to make sure delta isn't invalid. Alright. And then, once we've done that, we need to check if delta matches the J. Only then do we go to these cases. Alright, try that. No? Okay, so we've got 1, 1, 0. So we should be checking both 0, 1, 0 and 0, 1, 1. So 0, 1, 1 should fall into here. And then we go to -1. Uh-oh. Uh-oh. Ah, we need a special case here then. So if I is 0, because we don't need to create a gap now. Return, suppose you return 1. Hang on. So, because we don't want to go into the negatives, so we want... I guess we recurse, but we don't. We can just do this max of this and 0. We either subtract. If I is positive, we subtract 1. But if it's 0, we can just leave it at 0. Let's try that, because we don't care about gaps. No, that didn't fix it. Alright, let's just reduce this as much as possible. We're trying to match wildcard against 1. Okay. Okay, and that fails. Alright, so we've got 1, 1, 0. So here, see what we're doing. So it's trying 110, so it's trying 010 and 011, and it's trying 000. Okay, 011 should resolve to 000. Okay, and then 000 should be 1. That's vacuously satisfiable. Okay, well that probably needs to come first then. But wait. No. What? 000. Why is 000 not returning 1? 0. It's not that. It's not that. It should be that. It should return 1. Put this up as well, but why would I need to do that? Alright. Now it never covers 000. Okay, cancel that. Let's go back to what we had. I don't need to move stuff around. Where it was fine. Okay, so it's trying 000. Why is 000? Are we actually reaching this point here? It should be returning 1. Okay. Why are we never getting 1 out of this then? Why do you go to 000? Don't understand this. I'm trying to solve the most basic case here. Wildcard 1 should be 1. 0, 0, 0. Should return 1. Let's assume it does, because, I mean, it must. Or just, I don't know, print I, J, delta. Yeah, okay. So at 0, 0, 0, we enter here. Okay. And it returns 1. Why doesn't that propagate up then? Why are we getting 0? We only get zeros here. Who called 0, 0, 0? This one. 0. Result equals that. So that these ifs are not matching these elifs because I've moved stuff about. That might be part of the problem. Okay, move this up here. If elif, 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 that table result. Let's try that now. Alright, so alright, you know what? Let's change all of these to elifs because this is if I keep changing the order here, the problem is I want this to come before these two. Alright. But then this all gets messed up. So let's say elif, elif. Alright. There we go. Got there in the end. Alright, so now go back to the big one. Bigger one. 0. For fuck's sake. Wait, 1100? We're back to that again. Okay, go to this again. 1. 1101. 110. 110 is 1 here. It's matching wild card against the 1. Okay. But when I put all this back in, 110 should be identical, shouldn't it? No, it's what? It's 0 now, but it's still 110 still means match the wild card against the 1. How the heck? These are all zeros. Oh, this is such a mess. Okay, so 1, 1, 0. So why does that return 0 now? Okay, 1, 1, 0 will fall through here. And then we get 0, 0, 0. So 0, 0, 0 should get to here, and it should return 1. It never gets here. So 1, 1, 0, what is it trying to do? 1, 1, 0. Should 4, 3, 3, 2, 2, 1. Where is 1, 1, 0 falling into? 1, 1, 0. 1, 1, 0 should come down to here, and then it should go to 0, 0, 0, right? So if I put here 1, 1, 0, okay. And then that should go to 0, 1, 1, and 0, 1, 0. 0, 1, 1. 0, 1, 1 should come here. Why not? Zero, one, one. 011, we are doing 011. Where does it actually end up? It's not going to be there, it's not going to be... there. It should be here. If delta 1 is pattern j minus 1, which is 1, we should get there. Well, what if I is... what if I is... oh no. What if, maybe we need this. I is 0. If I is greater than 0 and that, because maybe if I is 0, okay, that fixes it. That's a very weird case there. If I is 0, then we don't care about a gap on the left. Okay. Well, that gives us the right answer now, but now what? $31. Stop printing all this stuff. One, 4, 1. 1, 4, 20. So how does that match up? It should be 1, 4, then 10. No, 1, 4, 1, 1, 4. Ah, so we're very close. We've got 1, 4, 1, 1, 4, but then we've got 20 instead of 10. What? So 1, 4, 1, 1, 4. So we need 10 here instead of 20. That might be a very easy fix then. Maybe there's just some one, like I'm doubling or something, or... So I'm getting 20, and I should be getting 10. So what's happened here? Oops, no, we don't want to print it that many times. Okay, let's look at the table then. So, apparently we've got too many things here. 1131 is 10. How did 1230 end up as 20? So that's 1230 is the whole thing. So the whole thing, we've basically looked at 10, 20 and 1131. We got 10 for each, and we added them together to get 20. So something... So we go to 11, 3, 0, and 11, 3, 1. So 11, 3, 1 is 10. That's probably correct. And 11, 3, 0. Is 10. 1131 is 10 and 1130 is 10. And they're saying it should be 10 arrangements altogether. That's too many. But it's interesting that we're exactly double. So... Is this part 1? No, this is part 2. I think the problem here is that this is doubling because the number of possibilities can coincide. I'm treating these as independent possibilities. I'm saying there are X number if there's a dot, and there's Y number if there's a hash. And so if there's a question mark, I do X plus Y. But that's wrong, because some of those actually match. Oh, damn. So what I actually mean is... so this line is wrong. I don't mean sum. What do I mean? It's not max. It's not completely obvious, is it? If there was a dot, we'd know how many possibilities there are. If there was a hash, we'd know. If there is a question mark, oh, we don't sum them. What do we do? No, we do sum them, don't we? I'm looking for the number of arrangements, which means, yeah, if I'm fixing that character, those are two different, distinct... If I'm fixing that at dot, that's a distinct arrangement from fixing it as a hash. Yeah, so that's fine. I can sum these. So what's the problem then? Getting double what I should be getting. Let's have a look at these early ones then. 530. So that's like 1, 2, 3, 4, 5 against all three. So that's impossible, correct? Ten to 0. Let me look at that one. So they're saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 against the pattern 3, 2. So there's a 3 there. So the remaining 2 could be here, 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 or here. It should be 5. How did we get 10? Alright, something's wrong here then. 10 to 0 is 10. So 10 to 0. Well, what's 9 to 0 then? 9 to 0 is 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I'm saying 3. So that's 1, 2, 3. I'm saying 6 when it should be 3. Okay. And what's 8 to 0? 8 to 0 is 3. So that's these characters. It should be 1, 2. There's only 2 spaces the other one can fit in. So I'm saying 820 is 3. Alright, let's try and fix that bit then. So take these out. Take these out. Run again. Reduce to the fault. Alright, so 820 is, I say 820 is 3. It should really be 1, 2. Alright, so what's 720? 720 is 1. We're saying 1. That's correct. There's only one place it could go. 720 is 1. 820 is 3. Alright, here's the problem then. So how did this come about? 820 is gonna go to 720 and 721. Alright, so 721 is 2. 1, 2, 3, 4, 5, 6, 7. 2, 1. You know what? I've just realized something. Something major. This delta is not necessary. Actually, there's a better way of using the delta. Alright, complete overhaul. We don't need the delta. What we actually need is just... I can't believe I even went down this delta path. So what we actually need is... we need to... If the pattern number is 2, for example, then we should actually just take the last 2 characters off. Say they're both hashes or whatever. Alright, let's redo this. So take out the delta. If j is greater than 0, okay, that's not irrelevant anymore. This one's not relevant anymore. Okay, so just go back to the basics. J equals 0, then return 1. Correct. If I is less than that, correct. Okay. Okay, that was correct. If it's hash... Alright, this is the bit where I introduced delta. What I should be doing is... Oh my god, I can't believe I did this. Alright, so what I should be doing is instead... num equals pattern j minus 1. Look at what the last number of the pattern is. Alright. If it's a hash, then we need to match. If there's a 3, or if there's a 2, for example, then we need to match not only this, but the next character along. So if any car is dot for car in Record, so it's from I minus num to I. So if there's a dot anyway, that makes it impossible to satisfy that clump, right? So we return 0. Otherwise, we just take off that clump and go to the next j. Are those numbers right? So we're saying there's that many. If num is greater than I, that's also impossible. Alright. And now this will be just a simple sum. That bit is okay. So if it's a question mark, okay. We don't want to do it here. Okay, so hello DJ. 2.5 hours. Yeah, I think I might have fixed it now. I was trying to do something weird with a delta. Okay, so let's just say if else. Okay, so else, there's two cases. Either Alright, so we want to try see what it looks like if we have a hash. So we got num blah blah blah, return any result equals that. So that's what it looks like if there's a hash. Okay, and if there was a wildcard there, we have to add in the possible arrangements if it were a dot. So okay. Sorry, if it's a wildcard, then result plus equal that. Okay. Okay. Is that any better? Two positional arguments. Yeah, we don't need 0 now. One. So 8-2 is 1. 1, 2, 3, 4, 5, 6, 7, 8, 2. Not quite, it should be 2. But we're getting closer, I think. 7-2 is 1. That's correct. 7-2, there's only one place for it. 8-2, there's two places for it. I see. Probably want to add in these then. Oops. We shouldn't be returning early. We need to accumulate the... 8, 2 is 4. Well, that's not right. 1, 2, it should be 2. Hang on, I might have added something twice here. Ah. Ah, we also have to add a gap. So we need one more character to form the gap. So we need... If any of those are dots, okay, then we can't make that combo. Okay, but we also need the left character to be a non-dot to be able to form to be a dot or a wildcard to be able to form a gap. So So if that's a hash, then that makes it too big. The contiguous section is too big, so that's also impossible. Otherwise, we can use it. We need to go one more. Alright, try that now. 8, 2 is 2. Okay, that's correct. Oh dear. Now for the bigger one. 10! Alright, now. Moment of truth. $18. 0, 4, 1, 0, 3, 10. Alright, well we fixed the 10. Now we've got a 3 there. 0, oh no, hang on. That should be a 1. Right, so probably the base cases are a bit too strict now. This is the chunk that's most complex, but it seems to be doing it correctly now. I think I'm being a bit too... Right, so for the easy cases, like what, -1? See, that's not good, is it? Let's go back to the original case that was failing. It was just literally just wildcard 1. I bet this is failing again. Gives an error even. Alright. Length record, length pattern. If i's less than 0, I suppose that's an error. Although, I'm not sure we should be ever having that case in the first place. Okay, so if I is 0 and j equals 0, if I is less than that, okay. So, and if record is dot, result equals that. Okay. Let me just see all the different things we're getting here. So -1, 0, that's okay. Alright, so the thing we don't agree with is 1, 1, 0. There is at least one possibility which would work. 0, 1 is 0, correct. That's impossible. But this one should be 1. Alright, so let's have a look. 1, 1 is gonna go... So it's gonna fall into this big chunk here. Okay, so num equals pattern j minus 1. So num is gonna be 1. So it's not bigger than I. If any car is dot for car in record I minus 1 to 1, result equals 0. That's not gonna happen. If I is bigger than 1, not gonna happen. Okay. So we fall into this case. Result equals... Probably just need to not go below 0 here. Okay, now we get the 1. Have we broken everything else again? No, we get 1. Alright. Now... 21. Alright, we've got it working on the test example finally. Now's the moment of truth. So it works on that. Okay, there, that's the full example. 1,000 cases, and they're quite big. But this is dynamic programming, so it should be quick. Oh, okay. Out of... I mean, that's a good sign. That means it's something stupid and not something subtle. Tuple index out of range. Num equals pattern j minus 1. Okay. So that means j is 0 here. If j is 0... Alright, so we'll handle the 0 case. So if I is negative, result is 0, okay. If I is 0 and j is 0, result is 1. Okay. If j equals 0, that means we're trying to match against a null pattern, which can only happen if all these characters are either wildcards or dots. We're not allowed any hashes. So result equals any result equals all are not equal to hash or in record up to and including I, up to I. So we're not allowed any hashes. If j is 0, then we have to basically have an empty record, a potentially empty record. And if that is possible, then we return 1. There's only one unique possibility. Okay, we've handled the j equals 0 case. 7025? I could have broken the test example by doing that though. We'll see. Not correct, too low. Right, let me check. I might have broken the test example now. Six. That's way off. What? Just by changing that? Okay, so that line I just added might have been too. Okay, let's think. If j equals 0, I'm trying to match the first I characters against an empty pattern. So I'm trying to say. But that's right, isn't it? If j is 0, also, okay, so if I is... Alright, let's look at the I equals 0 case and the j equals 0 case. So if they're both 0, it's 1. Okay. because they're both equal, they're both satisfied if they're both empty. Alright, if I is 0, what happens? We're trying to match an empty set of characters against a non-zero pattern. That can't be done. So that's 0. Okay. Otherwise, if j is 0, then that can be done as long as there's no hashes in the first I characters. So what's the problem now? Alright, go back to the classic example. Why is the IDE so slow? That's correct. Let's just print all the things then. One. It's saying 1 for everything. What the heck? How did... Is this too... If I take this one out... Oh, that's not the problem now. What? J being less than 0. Oops. Well, it shouldn't ever... No, I think it was 0, and then it was trying to access j minus 1, which is negative. So j was 0, and j minus 1 was negative. And it was trying to access a negative location. Right, so if I is 0, it means we're trying to match the... Oh! This is a question of semantics, really. Can we match a null set of characters? How many ways can we match a null set of characters against a pattern? No, it's still 0. It's still 0 is the right answer here. Alright, and with j equals 0, I think this is correct. It's it's 1 if it's 0 if there are any hashes here, because they stop us from being able to match the pattern. Otherwise, it's 1. Okay, so I think these base cases are correct. Why are we getting 1s everywhere? Just because I added these 2 lines? If I take these 2 out, what happens now? What? What did I change that caused 1s everywhere? Uh-oh. What did I change recently? Well, I mean, I think those lines are correct, but we should leave them as is now. So this should be 4. We're getting 1. What the heck happened? What did I change? Okay, so if I is 0 and j is 0, result is what? Correct. If I is 0, result is 0, j is 0, result is that. Okay. Result equals num array max I minus minus 1 0. So I've said if there's a dot, then we go on to the next one. That's correct. Yeah. Zero zero one, correct. 2 1 1. Is that right? 2 against 1. Oh no, I've done that thing again. I've not copied the input. I've copied the input where they've actually replaced the wildcards with fixed. Copied the wrong input. It's this one. There should be wildcards in there. So in the example, they actually replaced the wildcards with hashes to show one case. But that's not the input. This is the input. So of course it's going to be 1 1 1 1 because it's fixed. There we go, 21. Correct on the sample. I've got to stop doing that. It wastes so much time. Alright, what do we get now? 7025, same as before, which is wrong. Oh! We're not unfolding now. I forgot. We now unfold, so we're doing L2R2. We've got it working for the sample case, now we're doing L2R2. It's that huge number. Correct. Okay, a lot of time was wasted there from me trying to debug something that wasn't an error in the first place. It was just either I was trying to use this as input when it's actually supposed to be this, and the other case was I wasn't unfolding. Unfolding is what we ultimately want to do. Okay, so now when we unfold it, oh my god. Okay, so that was probably the least watchable video I've made out of all of these days. I think I'll try to clean up my code a bit. Oh wow, that's a low pass rate so far. exactly 3 hours. Only a couple of other people have done it. Yeah, on this leaderboard, on my leaderboard. Okay. Captain Coders. Yeah, a few people have done it, as expected. Okay. Fine. Five minutes 58. I mean, it's dynamic programming, so it's actually, for the top coders, it's not that hard to put together because it's just write a horrible recursion and let it recurse. That's basically dynamic programming in a nutshell. I think where I went wrong mainly was this bit here. So you can delete num characters, which could be a big number, which is good, because then you recurse on a much smaller record. If you're doing I minus num minus 1, then that's a much smaller record. But what I was doing was I was just removing one character at a time. So instead of going to I minus num minus 1, I was going to I minus 1 character at a time. The problem if you do that then is that you don't remember if you're now forming part of a contiguous section of hashes or not. You gotta subtract all the hashes in one big go. Otherwise you forget, if you're doing the subroutine now, you forget whether this should be part of that big contiguous array or not. So you have to subtract this block in one go and recurse on the much smaller remaining set. Yeah, the problem I was doing, I was subtracting one character and then recursing, and then you lose the knowledge of whether that's contiguous or not. Top 100 was 22 minutes. Yeah, so, I mean, that actually looks pretty clean now. I equals 0, j equals 0, I equals 0, and j equals 0. This bit here is an optimization. We don't even need that. We can probably take that out. It's the same. We don't need that. So yeah, that is... I mean, now we don't need to populate the table with all this stuff. We can just do return 1, return 0, return that, and then here we go result. So that should still yield the same answer. Yeah, okay. Take these prints out. Make sure we're not breaking it. Yep, that's fine. Take these out. Oh, just to clean this up, let's also make sure we print part 1 as well. How do we do that? Total 1, total 2 equals 0, 0. So this one is going to be 1, 1. This one is going to be 2, 2. Also, we don't need to call this arrangements 2 now. We can discard the old one. This was our old one. That was brute force. We don't need brute force anymore. Don't need iter tools. Num arrangements and take out the 2. There we go. 7025. Wait, what? Oh yeah. 7025 was the answer to part 1, wasn't it? So when I was getting 725 just a while ago, that was the correct answer to part 1, but I forgot about that. Yeah, okay. But I forgot to switch to part 2. Alright, fine. There we go. Let's make this nice and neat. Alright, that honestly doesn't look too bad now. It looked horrible when I had the deltas in there. Now it's just memoizing. We can simplify this a bit. Okay. Just add a comment, one comment here. Dynamic programming with memoization. Difficult to understand, to read. Because if I share this in Captain Coder's stream, then in his Discord, then I don't think anyone's going to understand this just by looking at it at first, but... Oh, whatever. Okay, I'm done then. Okay, that's been 3 hours on a dynamic programming problem. That's what happens with dynamic programming. It is actually one of the most hardest interview style questions, and companies love giving this as an interview question. Dynamic programming, because it always stumps people, and it's always a mess. But dynamic programming was the right approach here, I think. Whenever you notice a pattern, whenever you notice that you can discard the first character or the last character and recurse, then you're getting somewhere. So you would have failed the interview? Well, I got the answer. So I would have passed if the other candidate didn't get the answer. Yeah, 3 hours is a long time. But yeah, that totally could have been an interview question. I mean, it looks hard, but that's... well, yeah, interview questions are hard. But yeah, I mean, I probably would have failed the interview if I didn't finish that in an hour, that's true. And some other candidates did. But yeah, it's been a long time since I've tackled dynamic programming. I mean, it's good that he brought this up again. We need more dynamic programming questions because people have got to practice this stuff, because it's... Not only is it one of the most popular interview questions, but it's actually a very practical algorithm that applies to a lot of real-world situations. So it's actually one of the most useful algorithms as well. Dynamic programming comes up in a lot of situations. So yeah, and memoization is also... If I didn't do memoization, would it even work? So if I take this out, if I don't use the table, it might be too slow now. See, it's too slow now because it's repeating past cases which have already been computed before. So you gotta memoize. If you don't memoize, then it's not really dynamic programming, is it? It's actually just kind of exponential recursion. Dynamic programming, I think, well, I'm not sure how it's technically defined, but in practice dynamic programming, you want it to be polynomial, not exponential. But I think technically, if it's exponential, it'd still be dynamic programming. It's just really slow dynamic programming. I think normally you would want a polynomial number of subroutines. Here, it's quadratic because we're trying every possible value of I and every possible value of j, so that's quadratic. Also, Python, I believe, has a label that you can use to auto-memwise. I've never bothered using that. I always just write my own table, but apparently you can do that. I can't remember what it's like at memwise. There's something you can do, and it does something clever. I've never used it, even though it's existed for like a decade. I might look into that. Maybe I should be using that. It could be more efficient. Alright, so yep, that's it. Well, since it took me that long, I bet Captain Coda's now streaming. Let's have a look. Yep, he is. He's 16 minutes in. Alright.
I didn't quite.
Alright, well, let's head over to Captain Coda. I think he might still be on part 1. I can't really tell from the stream. Oh. Bad cop. Thank you for the raid. I literally just finished the problem now. 3 hours in. Well, it's okay. I was about to raid Captain Coda anyway, so that's well, thank you for the raid anyway. I was just doing a bit of cleanup in my code. I think I've done that now. This was a nasty problem, but I mean, it's dynamic programming, or at least that's the solution I used. How fast did you get it to run? I haven't timed it, but it's basically instant. I mean, it should be, because I'm using quadratic time per line. So, yeah. With dynamic programming, I'm using quadratic time per line, so number of characters, so yeah, it should be fast. Yours takes 10 seconds. Are you using dynamic programming or some sort of smart permutation thing? Interesting. I mean, dynamic programming in Bash is slow. Are you also memoizing? I suppose it's just, yeah, I guess it's just a case of Bash being hard to use for this purpose. Interesting, okay. Because if my parameters are I and J, I being the first I characters of this, and J being the first J numbers of this, then there should only be a few I's and J's per line, so yeah. At least the way I'm doing it. But yeah, I went on a horrible goose chase with a third parameter called delta. I don't even want to explain what I meant by delta. Let's forget I ever mentioned delta. So delta's gone. No more delta. Just 2 parameters instead of 3. So many edge cases in part 1. Yeah, once you start accounting for... Oh, in part 1. So in part 1, were you just doing brute force? Because I did that using ITER tools. Line 4 was at least 40 minutes wasted. Didn't brute force. Oh, so you did actually start with a dynamic programming recursion approach. You didn't memorize that all for part 1, fair enough. Yeah, I mean, it should still run with those sizes, I suppose. Okay, don't fork bomb me, bro, equals true. Yeah, I can't understand any of this, but it looks interesting. Line 4 was rough. Wait, line 4. Wait, am I whose am I looking at right now? Yeah. Bad cops. Oh, I got another raid. Oh my god. Well, thanks for the raid. Tempo Alex. I literally just finished after 3 hours of banging my head against the wall. So I'm just doing a bit of talking about what I did before I go on to raid the captain coder, because he's kind of 20 minutes into the problem. Giving up and going to bed. Oh, wow. Is this the first such day where you've resorted to giving up? And were you trying a dynamic programming approach? This is not, I mean, you can come up with dynamic programming from first principles, but it's definitely something which would benefit people who have actually practiced dynamic programming and done the sort of mathematical side of splitting a problem into polynomial number of subproblems. So it's a lot of the other problems, I would say someone who hasn't done CS could probably tackle them, but this one it's kind of benefiting those people who have studied algorithmic paradigms such as dynamic programming. Hacky brute force that ran in only 20 seconds for part 1, but part 2 was completely lost. Yeah, you can sort of, like, when you read the description, it doesn't really give you a hint at what kind of approach you want to take. It kind of hints that, oh, there's a kind of Sudoku-like approach where you can see that this first bit must be hashes, and then that leaves so-and-so left, but you can't really see how to make it rigorous. I think dynamic programming is the answer to that. It's how to make it rigorous, but it's not trivial. But I mean, it's a good problem, and this is fantastic interview practice because I've interviewed at companies before, and many companies love to throw dynamic programming at you. I mean, I interviewed at Google before, and I'm pretty sure at each of the 5 interviews they threw in dynamic programming. Like, they love dynamic programming. Do you think they would be okay if I took 6 hours on the interview? If it was a morning interview? I don't know. Nah. Usually there's like a 1 hour limit because the interviewers simply don't have time. They have to be, I was an interviewer before, so we have to get back to the office and get back to work, so they can't go on for more than an hour. I mean, several interviews I've done don't even have a machine. You're just supposed to code it all on the whiteboard, which is scarier because then you got to write on the whiteboard. So, but I would say that problem there is a realistic question you could get in an interview and be expected to do it on a whiteboard without an IDE within an hour, within 40 minutes if you're at Google or something. So. yeah, if you want to interview at places, you got to practice dynamic programming, or just hope there are some nice companies out there which don't care about dynamic programming. Because it's not something you write on the job, to be honest, that often, because usually there are libraries for this stuff. But the complexity of my original part 1 solution is unknowns to the power of 2. Yeah. Yeah, the same for me. That's what I did. ITER tools, Python ITER tools, product, and then I did product. It's basically doing the power set of power set of 2 elements. No, not power set. Cartesian product of the set of 2 elements multiplied by itself n times, where n is the number of wildcards. Yeah. That's why it's called product, because it's the Cartesian product. Okay, I get it now. But all in all, I'm pretty happy with my final code, and it's not that bad to look at after you look at the first base cases. Then, see, this base case I don't like so much, because that's using linear time. You want to avoid doing linear time in your base case. So ideally we would not have that. We would recurse. We would knock off one character and recurse. But it works, so whatever. So it would actually be faster if I didn't have this. This is a linear time operation. Everything else is constant time and recurse. So, but it's fine. Well, we can hope that tomorrow is a nice day. Alright, I got nothing more to say. I think we'll go and read the Captain Coder. Okay, I'll have a look at this before we go. This was the result of my whiteboarding this problem. Oh, I like this. So you got some Minecraft dirt and Minecraft obsidian. What is the reasoning for picking Minecraft blocks? Was this something to do with the nature of the problem? Oh, because it's lava? No. Do you just like the look of Minecraft textures? I thought it was something to do with because it was about making lava. But it's springs and... Okay. And then you've got... Okay. Something the obsidian one stopped the sliding window. Okay. Cool. Alright. I gotta stop there. I really gotta go eat now. I can probably watch Captain Coder for like 5 minutes maybe before I go.
Just because my brain...
Maybe dump my code on him so he can review it. No one should hire me ever. Well, I mean, if you're making nice diagrams in Paint, that's a point in your favor, definitely. I mean, I was an interviewer and we were instructed to, you know, look favorably on those who are actually making an effort to sketch things out, make diagrams and stuff, even if they don't get to the answers. So, and that was at Amazon. Yeah, if you're sketching stuff out, then you're hitting at least one of the criterion we evaluate on, but we do. One of the other criteria was that you do actually have to get to the right answer in the end. So, alright, let's go. I can't take much more of this. Captain Coda. Raid. Captain Coda. I don't know how many of the raiders are still in my chat. Hopefully at least about 50 or something. So, give him a nice big raid. And I'll maybe see you guys tomorrow. Hopefully earlier. It looks like I'm going to have to go earlier and earlier because it's taking longer and longer to solve these problems. So,
Dude, I'm gonna change my life to this thing.
All right, see you guys there. Bye bye.
So I don't break everything like I did last time. Stream